without further ado, I bet you're wondering what this robot does. I am. So Hans and Natalia from OptoFidelity are going to talk about robot-assisted test automation.
All right. Hello, everybody. My name is Hans Kuosmanen. I'm a VP of Test Solutions at OptoFidelity. I'm here with Natalia Leinonen, who's our senior software engineers. And we're really excited to have this opportunity to tell you guys about robot-assisted test automation. So the things that we're going to go through today, first of all, I'm just going to tell a little bit about who we are and where we're coming from. And we're going to tell you things about measuring user experience of mobile devices. Also the hardware testing landscape, where the requirements are coming from and so forth. And also when you should use robotics to test applications and devices. We have a short case story about Google Chrome Touchbot that we've delivered during the summer. And then we will have the demo, which everybody probably waiting for. If we have time, we're going to have some Q&A later on too. So first, I'd like to tell a little bit about OptoFidelity, partly because the marketing people just told me to, but also because I like to tell you what's the background of the company. So we're a Finnish company established in 2005, and we've been working with test automation for R&D for mobile devices. So we're kind of like hardware-centric people. We have a heavy competence in the optical test and measurement, so imaging, machine vision. That's pretty much the projects that we were working on in the beginning. And then at about 2008, we started getting more and more involved in robotics. The reason for that was the emerging of touch panels and touch sensing on those devices, on mobile multimedia devices. So far, we've been delivering solutions to pretty much all the major ecosystems, and also to most of the chip vendors that provide technology to smartphones and tablets. In the space of mobile device testing, we are pretty much the leaders in robot-assisted test and measurement automation, which means that utilizing robotics in activating the products, simulating humans. We're kind of building a human simulator for testing devices. The human-like UI performance testing is something that we are using high-speed cameras and external sensors to measure the actual user experience of the end user of the product. It can be either application or just the device itself. On touch performance testing, we have delivered systems for characterizing, calibrating, testing touch sensors, very accurate robotics involved there. The first project actually that we started off with was about video quality testing, so perceived video quality of mobile device. We have technology we can measure and analyze video directly from the screen of the device, because many times you don't have access to the actual video playback, or you don't have reliable access to it. And one thing that's pretty close to the video playback is the UI animation and how smoothly the UI is actually working. It also gives the end user the perception if the UI is good or if it's bad, if you have like frame skipping or things like that when you're actually operating, opening apps or switching to between apps and so forth. There's actually also some images of the type of robotics that we have delivered. So this is just one example. So we provide a lot of different platforms, a lot of different form factors for different applications. Then to the subject of measuring the user experience. I mean, user experience is kind of a large concept. So there's things like look and feel, and what kind of colors you need to have on the UI. That's not within our scope. So in our scope, we are looking for things that we can actually measure and give measurement results, raw data. There's a couple of things on the slide there that are contributing to a good user experience, and these things need to be in order for the end user to perceive the quality as being good. I just want to highlight a couple of things where robotics is going to add some benefit and some value to the testing. One obvious thing is the touch sensor. So there's really no other way to characterize, to validate the performance of touch other than having robotics in there and artificial fingers, styluses, and what have you. And the touch is really something that's emerging also to wearables and to cars. It's pretty commonplace already in the smartphones and tablets, obviously, but there's a lot of different applications coming up. Even just household appliances are having touch on it. So touch is really big thing. I'm sure there's a toaster with touch interface on it. So we are providing solutions for the touch accuracy, touch responsiveness. There's also proximity, like hover of the touch. That's another user input to the device. Also force sensing, and now like Surface Pro and the iPad Pro now the stylus seems to be coming back as an input solution or an option, and it seems that there's much more technology behind it. So it's not just the replacement of the finger. There's like angle and force sensing on those devices also. So we can provide the equipment, the methods to test and characterize all of this. Imaging is another very important area. I mean, we heard on the keynote that there's 300 hours of video being uploaded to YouTube alone per hour. And everybody's 20% of internet users they have an Instagram account. Everybody's posting, even me, posting their lunch pictures and breakfast to Facebook. So end users are expecting the image quality to be perfect and the video, recorded video, to be really good. So what that means is that the device manufacturers have to find ways of how to get a better image quality, how to get a better video quality. And it's not just adding more megapixels. It's like integrating the sensor, like acceleration, gyros, all this into the imaging chain. And this makes it very complicated to use software-based instrumentation in the product because there's so much interaction between these different hardware components inside the device. Then there's much more sensors being integrated into the products, like near field, wireless sensing, and gyros, acceleration, you name it. There's more and more stuff coming up. So the more complex the device gets, the more interactions you get, the more difficult it is to use software-based agents to measure and to test and validate. So we are focusing on doing all the testing non-intrusively, so we don't have anything running on the product. We're using external sensors, cameras. We're using robotics to activate the products, and this gives us much more robust way that works across different types of equipment and devices. So the UX being a very broad term, where are the requirements coming from? So, well, the requirements are coming from the end user. That's one of the reasons why we're kind of doing the human-like testing. We're trying to test the way that the end user is perceiving the operation and the feedback from the product. The app solutions, app and solution developers are kind of the in-between messengers to the operating systems, ecosystems of what kind of features the end users are looking at, and also finding new ways, new attractive features for the end user to want. So that information kind of gets into the ecosystem level, and then there's a whole complete value chain behind it for building those devices and validating the components that go into them. There's certification in some cases, like Google has the CTL, I think, and Windows has the HCK. So there are some requirements that come from the user, the end user level into the actual hardware and the components. But oftentimes it's just the equipment manufacturer that pretty much make up the requirements, make up the limits. And then all these limits go in, and the methods and the limits go into the value chain to R&D teams, to production of the equipment, to after sales, like refurbished business. All these guys are using the same requirements then. And our solutions, as they are like end-to-end non-intrusive ways, you can use them for all of these different players on the ecosystem. The other way to look at that is like the product life cycle. So first you try to validate the components and the actual bits and pieces and the chipsets and what have you. So the chipset and platform suppliers are doing most of the testing. The device manufacturers get into, once they start to integrate these into products, then there's going to be functionality, stability, and interaction of those hardware components. The device OEMs start to do most of the testing. And then once the products are launched and once they are like finalized and new versions come out, there's a whole area of system level testing that I'm pretty sure most of you guys are involved in, that involve the software, the applications, the server backends, and what have you. So you got operators and service providers, application developers are more doing the actual testing. But this might, it's kind of a living thing that some of that testing is kind of going back to the device level also. So there's, not all the platforms are very stable in a way that you have to take into account a little bit of the hardware, and that's why there's a lot of talks also in this conference about testing in the hardware. It's very important. You can't just go and test everything on an emulator. So instead of just using a device cloud, when would you be testing with a robot? Well, you could test everything with a robot, but a lot of times it doesn't make sense to have all your test cases run on that. But there are specific areas where the robotics is going to add a lot of benefit and a lot of test coverage to your test portfolio. Most important is the complex interaction. So more and more hardware components, more and more applications are running at the same time when your app is running. And oftentimes it's kind of hard to make sure that your test conduit or your instrumentation is not actually one part of that complex interaction and affecting your test results. Also, when you're using production software, you might not have all the instrumentation available. You might not have all the debug features and the hooks. Or if you're testing how your devices are booting, like this is more like operating system stuff. So if your device doesn't boot, how are you going to get your instrumentation software up and running? So a lot of times you need some sort of robotics, like just pressing the power button or disconnecting a power cable or something like that. In medical industry, there's a lot of regulations that you cannot have any instrumentation in your system. You can't even have extra hardware components in it to pull out a display to a frame grabber or something. So you don't really have the means to get the data that you could use on your test cases. Whenever you need controllable, repeatable UI actuation, that's also a robot will do it. You can do it per millimeter, even 100 micron, 10 micron even. So if you need to move the product around, for example, to activate the sensor layer of it, then robotics is the way to go. Also, if you need real-life sensor data, like image stabilization of a camera, for example, when you're optimizing your algorithms, it gives a lot of benefit to actually move the camera around, move the targets around in a predetermined fashion so that you can iterate your software using the same test conditions every time. Benchmarking against your neighboring operating system is also one thing that if you're doing it with software instrumentation, you're probably not going to be comparing apples to apples. You might have a little bit different performance of your software instrumentation on different operating system platforms. And then, as I earlier mentioned about the touch sensor, so if you need to do things very accurately to the 10 micron level, robotics is really the only way to go. And a lot of this is hardware centric, but some of this also trickles down a little bit to the software layers. Some of you might have heard about the Google Chrome Touchbot. So it's a system we delivered to the Chromebook team over in Mountain View. And what it's used for is used for measuring the end-to-end latency of the user interface on Android and Chrome OS devices. So it's part of like a continuous integration system where the new firmware uploads are getting automatically into the devices. And as you can see here, there's like 5 units on the same robot. And you can fit another 5 there pretty easily. So all of these gets the new software built into it. And then the robot will go and activate the product, actually a little bit similar way what we have here on the demo. And we're looking for things like how quickly the display is responding to the actual physical touch. So there's like 2 systems. One is the one in the picture has like a 2-finger actuator, so you can do also pinches and zoom motions. And then there's another one which is actually the biggest robot we've ever delivered, which has 1-finger actuation, but you can fit much more units under it to get tested during the integration cycle. But then it's demo time, so this is probably what you've all been waiting for. So I'll just go let Natalia do her thing. Can we get the previous slide in there, please?
Yeah.
There we go.
Okay, so here is the demo setup visible there. So we have an actual small 3-axis robot here, and it's equipped with a brass fingertip for interacting with the device, and a high-speed camera to measure the latencies of the graphical user interface, and also a small camera for navigating the UI and for configuring the location of the device. And can we have the live stream now? OK, great. So our software, which runs on this laptop here, provides easy-to-use programming interface. So the user who will use this robot to test devices doesn't need to know about anything about how to control the robot or about robot's coordinate system. Once we have configured the location of the device, then we can just say that tap on a certain location or swipe across the screen or take a screenshot and verify that there's certain icon or text visible on the screen. And in this demonstration, we'll be measuring so-called pen-to-ink latency, which is basically the distance between the fingertip and the line that is being drawn while we swipe with the finger. And There are also several other types of UI latency measurements, like, for example, how long it takes for device to react when user taps, or how long it takes for example, for camera application to launch, things like that. But now let's take a look at this demo here. It's a very simple Python script which will execute 3 identical swipes on this device. And it will measure the pen-to-ink latency for each of the swipe, and then plot the results on the screen. So let's start. So first, the robot opens our test application, which basically just draws a line on the screen immediately after receiving the touch, after detecting the touch. And we could use any painting software. The reason why we're using this here now is that we can be sure that there is no extra latency coming from the app itself. And here we're using a simple Python script. We have tools for creating simple measurements like this without knowing any programming languages, but creating Python scripts provides better flexibility and better integration to continuous integration tools or test frameworks. So here we're just providing an API that is easy to use and can be integrated into anything. OK, and now we have the results. And probably can't see it, but it's the pen-to-ink latency for this device, which is Nexus 4, is around 80 milliseconds. And usually, anything below 100 milliseconds is considered to be immediate. So the results are pretty good. So good. And yeah, that's it.
All right. So is there any questions?
Thank you, Hans, Natalia, and Robot. Let me sneak across. So it seems like the first one is it fast enough, including movement, image recognition, etc., to be applicable to game testing?
Well, this robot here is really a low-end thing. So you can get more speed with SCARA robots, Delta robots. The more problematic probably is going to be the image recognition part. We do have solutions for measuring frame rates, for example, directly from the screen. But detecting icons, and then it depends on how quickly you need to react to them. And at the end of the day, you can just build a server rack, behind it, and it's just math, pretty much.
Yeah, it depends on the game.
Yeah, but with a laptop, it's probably not going to work right now. We'll wait for a couple of years.
Yeah, but we're playing Angry Birds and Clash of Clans with this robot. You can see videos online how this robot.
Yeah, please go to YouTube and search for OptoFidelity. There's a whole bunch of fun stuff in there.
So how do you test your own testing machines are working?
That's a really good question. Well, we do characterize the robotics for accuracy and the timing with external equipment, like optical encoders and things like that. I'm not sure if that answers the question directly. We're using ready-made libraries for detecting icons, for example, if the question is more of, are we getting false failures or are we getting false passes? So we come from, the background for the company is from the image processing and machine vision. So we've worked with a lot of the image libraries for icon detection. But so we haven't implemented all of the algorithms behind it. We tend to more use the existing libraries.
Okay. It seems like this only makes sense financially to run in very high value scenarios. How feasible is it to roll
We just dropped down on it.
this out for functional testing? How feasible is this for functional testing for middle or lower finance or lower value scenarios?
Well, right now, what we're seeing is that this is used for a subset of testing. A subset, the things that cannot be done with software, or the software version or software instrumentation is not reliable enough. The robotics is developing all the time, so the prices are coming down, the speeds are going up, and in the near future, it might be financially more well, I mean, we're happy to provide all this stuff. That's not a problem, but right now, it's probably just a subset, but we're going to wait for a couple of years, and I'm pretty sure there's going to be a lot of low-cost robotics. I mean, there's like 3D printers coming out every day, and all this development goes into the robotics. And we're kind of harvesting on that.
Great. I do have time for more. How is this robot controlled? Can it talk using Java? And how is the validation done across different devices? Like, do I need different scripts for different devices?
Yeah, so the API that we're using is actually HTTP. It's like a REST interface, so that'll work pretty much with anything. So if you want to use Java, that's perfectly fine. We provide like a Python library or a wrapper, and I think
C#, C++.
Yeah, so the interface is really simple, and then the tools for doing the configurations and like positioning the device and all that, those come with the system anyways. So the interface when you're building your scripts is really simple, and you can use pretty much whatever language you want.
What about reusing the same script on multiple devices? Say you have a Nexus 4 and a Nexus 10 that you want to run, say, that speed test on. That's
possible because we actually the icon detection that we're not using bitmap comparison on the icon or the OCR. So if the display sizes are different, even if the color scheme is a little bit different, it will adapt very easily. Obviously, you can write a script that doesn't work, but it's always a possibility.
Yeah, as long as the navigation logics doesn't change, then it should work.
And one last question. Are these robots meant primarily for development, or are they something that might be used for sampling of the entire production run?
Well, we have delivered robots for production of devices, of equipment. So we're using the same technology or parts of the technologies. It's not identical to this. So typically the type of things that we're demoing here, these would be on an R&D team would be interested in this kind of results. But we're using the same technology. We have some robot platforms that we use on production line. And the technology that we've developed, some of these like the actuations, like the fingertips and the locationing of the device, we have automatic locationing. That is also used in production.
Well, thank you again to the two of you and your robot.
All right, thank you.